Hello, my name is Adam Kacmarsky, and this is my AI course project for Computer Science 4550, Introduction to AI, which is offered at the University of Wyoming in the fall 2014 semester. Today, we're going to look at one-dimensional search agents in Atari 2600 games. First, let's talk about some software that I used. The main program was built in the Arcade Learning Environment, or ALE. ALE is built on top of the Stella Atari 2600 emulator and allows direct interface with Atari ROMs. Specifically, we are going to be using the shared library interface, which allows direct interface with the ALE environment. Next, let's talk about some terms. A one-dimensional game is any game in which the player can only move in one dimension, for example along the x-axis or the y-axis. A search agent is a program that searches through all possible states and returns the best reward, which is the amount of points that you get. Let's look at our first game that we're going to play. We're going to be playing Breakout today. The point of Breakout is to bounce the ball off the bottom paddle and break all the bricks on the top. In order to do this properly, we need to allow the agent to search through all possible states and return states in which it scores points and doesn't lose the game. Let's take a look at a video that shows what the agent is doing at every step of the program. Here we can see the agent iterating through all of the actions that it can make in either direction and then pausing to allow the ball to travel through the space. If it scores any points, it returns the amount of actions that it needed to take to get to that position and then the amount of times it waited. It does this through all states possible until it returns a reward. As you can see, it takes quite some time for it to even score a point. However, in the original version of this program, it searched through all possible states at every position of the ball. This wasn't very efficient, as not all moves matter in this game. When the ball is traveling, the moves that you make with the paddle don't necessarily affect what the actual outcome of the score is. In other words, the reward isn't affected if the ball is not hitting a brick. As a result, we needed to implement some sort of waiting function in order to let the ball travel after we do an action. This will allow us to correctly determine whether or not a reward is gotten for the actual action, or whether it's just a reward for some action that didn't necessarily make any difference. Again, this takes quite some time to do, but is much faster than searching through every state. Additionally, this program can be generalized to other games that act in one dimension. For example, Pong or Space Invaders will also work, as when we get the minimal action set, it will return all possible actions for the game, not necessarily like left or right, but for Pong, return up and down. As a result, we can play pretty much any one-dimensional game with this as long as we set the depth to the correct amount, which is different for every game. So now that we've had a look at what the program is actually doing, let's take a look at what it does at the endpoint. As you can see in this video, the game is played fairly well by the program. It can even play off of the sides of the paddle or even the bottom of the paddle if it's next to a wall. This is because the agent knows that it can hit the ball off of those positions and get a reward. The reward isn't the top reward possible for the game, but it gets fairly close. The top reward possible for any Breakout game is 896. Running this agent for around 30 minutes or so will get a reward of 864, which is when the game ends. This is around a 96% efficiency rate for this algorithm. As you can see, it's doing pretty well. Finally, I'd like to thank some people who helped me out in my project. I'd like to give thanks to Bonnie Vitello, Aaron Locke, Stephen Boyer, Alfred Moreira, and Richie Yang for helping me with the ALE project files. I'd also like to thank Bonnie for creating these slides for me. I'd finally like to thank Jeff Kloon and Yus Tazinga for being wonderful instructors for this course. Thank you.